Hello dear friends, welcome back to MACSGATE. One second, I'm hearing my voice. One second. Hello. Hello dear friends, welcome back to MACSGATE. We are learning probability and statistics. In today's session we have introduction of statistics. Okay. See, actually as I mentioned, this probability and statistics for data science and artificial intelligence students, it is divided into three parts. So in this first part here I am just discussing the statistics basics, which is common for all branches. And when you are talking about statistics part for DS and AI, then we try to discuss in more detailed manner. So this is common for all branches. It is required for all branch people. Okay, so don't ignore this. Am I clear? Please note that. Statistics. See, statistics is the art of learning from data. So we are going to learn from data. In statistics, from data or from distribution, we are going to learn. We are going to get the information. Okay, and what statistics actually do, sir? It will characterize data or the distribution. So we can characterize, we can give the properties. That is, we can make some decisions, we can make some generalizations from data. Of course, for that we need to analyze the data. We need to first summarize the data. We need to interpret data. So they're all involved in that. Okay, so when you talk about statistics mainly concerned with collection of data, organization of data, description and summarization of data. When I say description, means sometimes in once you have a data, you may be representing using different methods like graphical representation, bar diagram, pie chart, etc. So that is can be called as description. Different ways of describing your data. Summarization means there are some summary statistics which we are going to provide for particular data. In today's session, we talk about this summarization of the data. Analysis of data. So we make analysis based on the results which you get. Then we interpret the results and make some conclusions. So making conclusion means like making some generalizations and giving some decisions about the data. Am I clear? Suppose if data correspond to a particular organization, you can help them by giving a proper decision about the data. Am I clear? That is the basic idea about statistics, my dear friends. And when you talk about statistics, of course, there are many things which are involved, like collection of data, organization. Okay, that all like very basic details how we need to first of all, before making summarization or before analyzing data and interpreting data, we need to do this collection of data, organization. That all comes as the basic study. Once you do the basic study, once you have data, then you can make some measures. There are some measures which can tell you about information or characteristic or properties of the data, and for that we are having some measures. Okay, so we are having measures of central tendency, we are having measures of dispersion, we are having measures of skewness, we are having measures of kurtosis, etc. So in this session we are going to mainly talk about two important measures. One is measure of central tendency, the other one is measure of dispersion. We try to discuss some important measures of central tendency and some important measures of dispersion also. Of course, I also introduced the idea of measure of skewness, but that is only for understanding purpose. We are not going to actually find the measures for that. Okay, we just try to understand what do you mean by measure of skewness. That is the basic idea. Now, what do you mean by measure of central tendency? So measure of central tendency is measure of position. So here the measures of central tendency are the measures that indicate the most typical value or center of the data set. That is, the central or the most typical value of that particular data about which the data is distributed. Okay, you can consider this as like some center of the data about which the data is distributed. Okay, so that is what you mean by measure of central tendency, my dear friend. So we are going to identify a typical element about which the data is distributed. So that is what you mean by measure of central tendency. And we are having three important measures of central tendency. One is mean, the second one is median, and the third one is mode. So these are the three important measures of central tendency. So for ungrouped data, we try to see how to find this mean, median, and mode. Even for grouped data, we try to understand how to find this mean, median, mode. Then we have measure of dispersion. What do you mean by measure of dispersion? It is measure of spread or variation. Okay. See, in using measure of central tendency, you find a central value, okay, about which the data is distributed. Now I want to know how much the data is distributed. Okay, what is the spread of the data about this central value? The measures of dispersion will give you the spread about this central value. Am I clear? And the degree to which the numerical data tend to spread about an average value. The degree to which the numerical data tend to spread about the average value. Here average value means the measure of central tendency about which the numerical data tend to spread is what is called as variation or dispersion of the data. See, even though you can take any central value, but mostly we take that particular average means the mean only here. Mostly we find this particular dispersion about the average value of the data. That is, from average value, how much the data is spread. So these measures of dispersions are going to give you this particular measure of dispersion, spread about the average value. Of course, here there are many measures. Variance and standard deviation are the most important one. We also have like range, okay, and we also have different percentiles or quartile deviations. Different methods are also there. When you talk about statistics, mainly when you talk about machine learning and all, we are going to talk about all other measures of dispersion. But here we are mainly talking about the variance and standard deviation. Range is very simple, sir. It is simply maximum minus minimum. But there is a lot of problem with this range. Suppose you are having a small value which is very much deviated from original data values and large value which is very much deviated from the data values, then range cannot be a proper measure of dispersion. Okay, so generally they don't consider range as a very good measure for dispersion. So they consider this variance and standard deviation as the very good measures of dispersion, spread about this central value. We try to understand with the example. Hello sir. Pehchana Krish. Pehchana Krish, how are you? Hope you are doing good, Mr. Krish. Now we got this measure of skewness. See, the measure of skewness is the degree of asymmetry. It will give you the measure of asymmetry. See, what it will give you, the lack of symmetry or deviation from this symmetry. See, yeah, I'm fine, sir. See, when you are having particular data, it is evenly distributed about this central value. That is, on the left side the distribution is same, and the right side also distribution is same. That is, when the data is evenly distributed about the central value, that is what you call it as symmetry. But when this symmetry is lost, then we call it as skewed. Then the data is called skewed. Okay, so this is what you mean by the data is evenly distributed about a central value. We call it as a symmetric distribution. And when the distribution is symmetric, the mean, median and mode will coincide. This is a very important gate questions. They are all very good candidate questions. For a symmetric distribution, what is the relation between mean, median, mode? They are all equal. It's not like only you are hearing and only you hear the entire class, my dear friend. It is an open channel. Later on, many students are going to hear. So for everyone, this particular concept is explained. Am I clear? Hope you understand that. Now the positively skewed distribution. Now, as I told you, If the data is evenly distributed about the central value, then it is called symmetric distribution. Okay, if the data is evenly distributed about the central value, it is symmetric distribution. But if the symmetry is lost, then it is called skewness. If the skewness is towards the right side, then it is called positively skewed distribution. That is, the symmetry is lost towards which direction? Positive direction. The symmetry, that is, the asymmetry is happening. Lack of symmetry is happening towards the positive direction. Then you call it as positively skewed distribution. Hope you understand? Clear to you all? Very good. Now there is one very interesting question about the relation between mean, median and mode. Already told you about this symmetric distribution. The mean, median, mode are equal for symmetric distribution. If you consider the positively skewed distribution, always remember mode means the most frequent value, the value which occurs most of the time. So this is the highest value and the corresponding value is what is called as mode. So this value is occurring most of the times. So this corresponds to mode. And mean is somewhere, because it is an average, so somewhere between the data, it will be somewhere here. And between mean and mode, your median will lies. Always median lies between. It's not exactly middle of that, sir. Somewhere between mean and mode, the median will lie. So now tell me, what is the relation between mode, median and mean for positively skewed distribution? Please remember, the values on the x-axis are the mode, median, mean values. So generally what people feel that mode is highest. See, the value for which, okay, the value which occurs many times is the mode. It does not mean mode is the highest value. Mode is the value which occurs most number of times, most frequently. People misunderstand the highest value is mode. No, highest value is not mode. The value which occurs more frequently. The value for which the frequency is more. That is mode. So this is mode. So on x-axis, if you see, mode is smaller than median, which is smaller than mean. So this is the relation between mode, median and mean for positively skewed distribution. This is the relation between mode, median and mean for positively skewed distribution. Am I clear? Of course. If you can write in the reverse direction, that is, mean is larger than median, which is larger than mode. Anyway, you can write either this way or this way you can write. Now, what about negatively skewed distribution? The lack of symmetry is towards the left direction. The lack of symmetry is towards the left. That is, symmetry is lost in the negative direction. Because of that, we call it as negatively skewed distribution. Am I clear? So, this is the mode. Mean is somewhere the average of the data. And what about median? Somewhere between them. See, somewhere between them does not mean exactly between half the way between mode and median. No, please don't take like that. Median is somewhere between mean and mode. Now, what is the relation between them? Here, mean is smaller than median and which is smaller than mode. See, this relation they asked in GATE examination 2-3 times. So, one of the important question. What is the relation between mode, median and mean for negatively skewed distribution and positively skewed distribution? So that is the relation. So here mean is smaller than median, which is smaller than mode. Hope you understand. Now let us see how to find the measures of central tendency. So what are the measures of central tendency, sir? We are having mean, median and mode. See, what is the mean, sir? The mean of the data set is the sum of observations divided by the number of observations. So generally, if you want to say, mean is the most commonly used measure of central tendency. Generally, it represents the average value. It represents the average value. So for ungrouped data, suppose you are having x1, x2 and so on, xn, the mean is nothing but sum of the values divided by number of the values. Of course, mean we denote it by mu, sir. Mu is the symbol used for mean. It is the symbol used for mean. Is that clear? Right? Of course, you can write the summation notation. Instead of writing x1 plus x2 plus and so on xn divided by n, you can use summation notation. Summation going from where to where? I is equal to 1 to n xi divided by n. So that is the mean formula. So let us take this example. Suppose the marks obtained by 10 students in an examination is 68, 79, 38, 68, 35, 70, 61, 47, 58 and 66. Find mean. So what is the mean, sir? Sum of the observations, that is 68 plus 79 plus 38 plus 68 plus 35 plus 70 plus 61 plus 47 plus 58 upon number of values. Okay, feel free to use calculator, because in GATE calculator is allowed. Suppose if you are writing some other examination where calculator is not allowed, feel free to add them. Add and divided by number of observation. I think this is 590 is the sum. Please verify that. Divided by 10. So what is the mean, my dear friends? The mean of this particular data is 59. Okay, so this is the formula. Now I want you to remember two important results here. Two important results. Suppose you are having data x1, x2 and so on, xn. Now what if I add and assume that the mean of this data is, mu. So by adding constant to each xi, suppose you are adding constant to each of these xi, what happens to the mean? So what will be if I add c to each xi, that is your new data is like x1 plus c, x2 plus c and so on xn plus c, then what is the new mean? What is the new mean? So let us call it as old mean. Then what is the new mean? See, in this case, whenever a same constant is added to every data or every data member, the new mean is simply old mean plus whatever constant you added. And same is the case when you multiplying. Okay, sorry. Suppose you are multiplying with a constant to each xi. So if you are multiplying a constant to each xi, then what happens? What is the new mean in this case, my dear friends? In this case, the new mean is old mean into c. So the logic is very simple. If you are having data members x1 to xn, to each data member if you add a constant c, then the new mean is old mean plus c. To each data member if you multiply a constant, the new mean is old mean into constant. So that is the point to be noted. Got it? Now look at this question. Suppose the marks obtained by 10 students in examination is given, and he also mentioned average. Suppose if he not mentioned the average, you have to find it. So here what is the average, sir? Average is 59. Now if teacher decided to add 5 marks to each student, then find the mean of the new data set. Because for every data member you are adding 5. See, one way of doing is add 5 to each data member, again find new mean. That is one way of doing it. Otherwise, because if you add constant to each data member, then the new mean, so you can call this as old mean, adding 5 to each student, you get the new average. The new average is old average plus 5, that is 59 plus 5, yani 64. Is the idea clear, sir? It is one of the very important and easiest result. Please remember, examination this type of questions are very common. Hope you understand. Same story, 10 student, marks are given and teacher has decided to scale down each marks by 40%. Scale down means what, sir? That is, the marks are reduced to 40%. Now the original marks are 100 means Teacher given only 40 marks to student. Okay, so you just need to multiply that by 0.4. Each student score you have to multiply by 0.4. Then find the mean of the new data set. So already old data set mean is given, which is 59. Multiplying, okay, marks or each xi by, I am simply calling it as xi by 0.4 because it is scaled down to 40%. That is, you have to multiply the marks with 0.4. 40% means 40 by 100, which is 0.4. Then what is the new mean, my dear friends? New mean is 59 into 0.4. Just multiply to get the required answer. So 4 9s 36, 4 5s 20, 23. One decimal. 23.6 is the new average. Okay. So average is very, very less. Original average was 59. After scaling down each student mark to 40%, the new average is 23.6. Is that clear? Now, for group data, of course, for group data again we have different formulae again. But here I am giving you the basic group data where we have data and each data is repeated more number of times. So instead of each data value repeated one time or two time or a single time, each data value may be repeated multiple times. So what happens, instead of writing all the data values, we can use what is known as frequencies. That is, we can create the frequency table. Using the following formula, we can find the mean. That is data value. How many times the data value is repeated? Frequency means how many times each fellow is repeated. See, even if you see the previous example, there is a data which is repeated. For example, if you see this, 68 is, I think 68 or anything, 68 is repeated two times. But there are not, no other value is repeated. Is there any other value repeated? None of them. Okay, if it is repeated, no problem, but no other value is repeated. So better way is direct method. But if some values are repeated two times, some value is repeated three times, instead of doing this way, we can also use what is known as frequency here. That is value to be multiplied with frequency. Okay. And frequency means what, sir? Each value repeated how many times? So how many data values are there? Some of the frequencies, if you do, you're going to get. For example, 1, 1, 1, 2, 2, 2, 3, 3, 3, 3. So here we are having only three distinct data values. 1 is repeated 3 times, 2 is repeated 3 times, and 3 is repeated 4 times. So this is what you mean by frequency table, my friend. So we are going to count how many times each value is repeated. And now we are going to use the following formula to find mean. Sigma fi into xi. That is, we multiply each xi with fi. Because 1 is repeated 3 times, instead of adding 1 plus 1 plus 1, I am simply doing 1 into 3. Instead of adding 2 plus 2 plus 2, I am doing 2 into 3. Instead of doing 3 plus 3 plus 3 plus 3 4 times, I am doing 3 into 4. That is what I am doing, nothing more than that. So this will give me sigma fi xi and this will give me sigma fi. So it is the same formula, sir. But instead of doing directly, we are using the frequencies and we are solving or we are finding the mean using this frequency formula. That is sigma fi xi divided by sigma fi. Is the idea clear? So here there is a question given. So let us solve this. Let us consider the data set 2, 1, 3, 4, 5, 2, 3, 3 and something is given, which are 15 responses of the 15 individuals. Then we need to find mean. Find mean. So here you can just write down xi values. What are the values we are having? We are having 1, we are having 2, we are having 3, we are having 4 and we are having 5. That's it. Only 5 values with repetitions are there. So generally they use this tally marks, like creating frequency table, they do it. So 2 occurred one time, they just give 1 for this. 1 occurred one time, then 3 occurred once, 4 is occurred once, 5 occurred once, then 2 again occurred, 3 again occurred, again 3 occurred, again 3 occurred, 4 occurred again, 4, then 1 second time, 2 occurred, 3. See, when it is 5th time, you cross it. Okay, that will tell you that 5, then 4 again occurred. So what is the frequency of 1? 1 repeated 2 times, 2 repeated 3 times, 3 repeated 5 times, 4 repeated 4 times, and 5 repeated 1 time. Only 5 1 time. So if you add them, you are going to get 15. So this is sigma Fi, sum of the frequencies. So what else you are going to do, sir? You are going to find sigma Fi into Xi. Then we are going to find the sum of these fellows. So what is the product? 1 into 2 is 2. 2 into 3 is 6. 3 5 is 15. 4 4 16. 5 1 is 5. Adding them, you are going to get the sum of the Fi Xi values. That is, we are going to get the sum of all observations. Indirectly, we are going to get sum of all observations here. So what happens to this? It is 31, 36, 36, 42, 44. So sigma Fi Xi is 44. Now what is the mean, my dear friends? Sigma Fi into Xi upon sigma Fi. So what is it? 44 upon 15. You can use calculator to simplify the value, my dear friends. I think I already calculated. I think it is 2.93. Okay, please check it out. Please check this, sir, once again. This is 2.93. Is the idea clear? So that is about the mean of the data. When there is a repetition, we can use the frequency table. Sometimes directly they give you the frequency table, then it is much easier. Directly find sigma Fi Xi and sigma Fi. Sigma Fi Xi by sigma Fi gives you the mean of the data. Is that clear? And sometimes they give you that classes they give you, like 10 20, 20 30, 30 40, 40 50, and they are going to give you the frequencies. Okay, so in this case you can't have this Xi value, so you can take the mid value of this. Okay, we call it as like class mean. So central value 10 plus 20 by 2, that is 15. These fellows becomes your Xi values. 20 plus 30 by 2, that is 50 by 2, 25, then it is 35, then it is 45. Frequencies, whatever they give you, you can use it. Again, the formula is same. So sometimes instead of giving directly Xi values, they give you the class intervals. Then we need to find the class median of the class we need to find. Okay, Xi we call it. That can be found like left value plus right value divided by 2 gives you this Xi value. Like 10 plus 20 by 2, 20 plus 30 by 2, 30 plus 40 by 2. Okay, so that you can use, and remaining story is exactly same. Frequencies they again mention here. So sigma Fi into Xi divided by sigma Fi give you the formula for that. Okay. The next measure is median. See, the median of data set is the middle value in its ordered list. That is when you order the data. That is when you sort the data in, say, ascending order, the middle value is the median. Okay, so generally median represents the central value, my dear friend. And you may ask me, suppose if you are having 5 values, third one is the middle value. What if I am having 6 values? In that case, what happens? 6 values means what, sir? Left side 2, right side 2. These 2 are the central values. So what you take? Average of the 2 central values you are going to take. Am I clear? Suppose if n is odd, n plus 1 by 2 is the n plus 1 by 2th element is the median. But n is even, then we are having this, for example, n is equal to 6 you are having. Then what you are going to take, sir? N by 2, n plus 1 by 2th observation. These 2 observations you are going to take. Take the average of those 2 observations. That is 6 by 2, third observation. 6 plus 1, I am sorry, it is not n by 2 plus 1, not n plus 1 by 2, it is n by 2 plus 1. That is third observation, 3 plus 1, fourth observation. So take average of these 2 fellows. You take these 2 observations and take average of these 2. That is nth observation. Yeah, I mean n by 2th observation, n by 2 plus 1th observation average you are going to take. That is how we are going to find median. So the median of the data set is the middle value. So when there is a single middle value, that is your median. When you are having 2 mid values, average of them will be your median. See, when the data is sorted, the middle value or average of middle values is known as median. Hope you understand. In other words, median of the data set is the number that divides the bottom 50% of the data from top 50%. That's it. So what is the median of this particular data? See, when you want median, the data should be sorted. Luckily here sorted data is given. So what happens? 7 points are there, 7 data values are there. Middle one is 7 plus 1 by 2. See, when n is even, n plus 1 by second observation is median. Median is n plus 1 by second observation. When n is odd, then it is average of n by second and n by 2 plus 1th observation. Average of these two observations. That is the median. Luckily here n is equal to 7. So 7 plus 1, okay, 8. 8 by 2 means 4th observation. So 4th observation is median. So what is the median of this, my dear friends? 6 is the median. Is that clear? Now suppose the marks obtained by 10 students in the examination is given here, 68, 79, 38 and so on. If teacher decided to add 5 marks to each student, then find median of the new data set. See, the story is exactly same as mean, sir. So for each data value, if a constant is added, the average or the mean, या median, या mode of the new data set is old median or old central tendency value plus constant. If you multiplied old central tendency value into C, same story, no change. Only instead of mean, here we are going to use median. But for finding median, you have to sort the data. You have to sort the data. So here, what is the least value? 35 is the least value. Then next, because if you want to find median, first you have to sort the data. After 35, you are having 38. Let us cancel like this, whatever is completed. After 38, it is 47. After 47, any 40s? No. Then there is a 50s. 58. After 58, there is a 61. There is a 66. Then we are having 68 2 times. 2 times you have to write it. Then, oh sorry, 70 I missed. After 68, okay, 68, then only 70 will come. 68 2 times, then 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 5. Some value I missed. 79. Okay. Okay. So that is the order list. Because n is equal to 10, even number. I think I made a mistake. Sorry. When n is, sorry, this is the reverse which I given. Sorry for this. It's the reverse one which I given. When n is odd, this is the formula. When n is even, this is the formula. Sorry for that. Okay, because when n is odd, we have only one mid value. But when n is even, we are going to get 2 mid values. Sorry, it is reverse. Sorry for that. Okay. Okay, fine. So now n is even. So we are going to take n by 2, that is 5th observation. 1, 2, 3, 4, 5th observation. And the next observation, that is 61 plus 66 divided by 2, which is the median. Okay. So what is it? 127 by 2, 2 6s, 2 3s, 63.5 is the old median. It is the old median. Okay. Median old, which is 63.5. Now 5 marks are added to each observation. Then what is the new median? So the new median will be median old plus that 5. So 63.5 plus 5. 68.5. The next one. Suppose the marks obtained by 10 students in an examination is given, and teacher decided to scale down marks by 40%. That is, each marks are reduced by 40%. So original marks 100 means new marks are 40 marks. Now, what is the median of the new data set? First, find the median of the old data set. What is median of the old data set? We already found that is 63.5. I am not doing it again. And when each marks is scaled down by 40%, that is new marks, that is for each marks we are multiplying, that is each data value we are multiplying by 0.4. So what is median new? I am simply writing M for median. That is 63.5 into 0.4. You can use calculator to get the answer, my dear friends. If you are having calculator, you can simply find. Let me use that. So what is it? 63.5 into 0.4. So 25.4 is the new median, my dear friends. Very good. Now let us move on to the. Now here, if you observe the similar problem where you are having frequencies, in this case, how to find median? So let us do this problem quickly. Xi values and the frequency. So here we are having 1, 2, 3, 4, 5. So 1 is repeated 1 time, 2 times. 2 is repeated 1, 2, 3 times. 3 is repeated 1, 2, 3, 4, 5 times. 4 is repeated 1, 2, 3, 4 times. 5 is repeated only 1 time. So here total 15 values. So we are having total number of observations is 15, odd. So median is 15 plus 1, 16 by 2th observation. Median is 8th observation. So here we are rating the values in the orderly manner here. Xi values you are writing in the orderly manner. 1. So we are having 2 1s. Then we are having 3 2s. So where will be the 8th observation? So here 5 observations are gone. Then next 5 observations are 3s. So in these 3s, 8th observation is also 3. So what is the 8th observation, sir? 3. So median is 3. What is the median here? 3 is the median. Is the idea clear? 3 is the median. The next one is mode. What is mode, sir? Mode of a data set is the most frequently occurring value. The value which occurs most number of times. The value which appears more number of times is what is called as mode. Please note, we can have unimodal data set, we can have bimodal data set, we can have trimodal data set, because mode need not be unique, my dear friends. Okay, there may be one value which is repeated most frequently, then it is unimodal. Suppose there are 2 values which are repeated most number of times, then it is bimodal. So we can have multimodal data sets also. Please note that. So what is the mode? The value which occurs most number of times. Here we need not sort, sir. So for mean and mode we don't have to sort the data. For mean, average, whereas for mode you have to identify the one which occurs with more frequency. So which one is occurring with more frequency, my dear friends? 3. So what is the mode of this data? 3 is the mode. The mode of this particular data is 3, because 3 is occurring 2 times. Remaining all values are occurring one time only. Suppose if you are having one more, say 7. See, let me write a different data set. Suppose if you are having, say, 1, 5, 4, 3, 3, 6, 7 and 7, then we are having 2 modes. What are the modes? 3 and 7 are the modes. It is called bimodal data set. Please note that. Now look at this. Suppose the marks obtained by 10 students in an examinations are given and average marks is given as 59. If teacher decided to add 5 marks to each student, then find the mode of the new data set. See, for mode you don't require this average marks. Sometimes they may confuse you with unnecessary information. Average is needed when you want to find mean. Mode is not the average value. Even median is not the average value. Average means mean. Please note that average means mean. So this is unnecessary information given. So first you have to find old mean, old mode. What is old mode? The one which repeated more number of times, that is 68. Now to each data set 5 is added. So what is the new mode? Old mode plus what is added? The constant. So what is old mode? 68. What is the constant which is added to each fellow? 5. 68 plus 5, that is 70. Is the idea clear? Even here same story. This is not required. Unnecessary information. Sometimes they may trouble you like that with additional unnecessary information. Please be careful. Now teacher decided to scale down, same story, same problem, but here we need to find the new mode. Find the mode of new data set. So what is old mode? Old mode is 68. Now what about new mode? 68 to be multiplied with 0.4. 4 8s 32. 24 plus 3, 27. 27.2. 27. Please check that, sir. Correct, only 2. Okay, so that is your new mode. See, whenever you are having a central tendency value, please note that whenever you are having any central tendency, old central tendency is there, and adding C to each xi is done, then new central. So I'll just use this central tendency, I denote it by mu only. Okay, I just denote this central tendency by mu, sir. Suppose old central tendency, I denote it as mu old for simplicity. Then what is new central tendency, which I denoted as mu new. So the mu new will be mu old plus constant. And what if I multiply each xi by c? Then in this particular case, the new central tendency, here when I say central tendency, it can be mean, median, yeah, mode. Old central tendency multiplied with that particular constant c. Please note that. So here if you remember this particular data set, same data set, suppose if the frequency table is given to you. So here this is given, you can find frequency table, or directly frequency table is given to you. So here 1 repeated 2 times, 2 repeated 3 times, 3 repeated 5 times, 4 repeated 4 times, 5 repeated 1 time. Which one is repeated more number of times? 3 repeated 5 times. So what is the mode? The mode is equal to. So if frequency table is given, finding mode is very simple. The one which is having highest frequency is the mode. Is the idea clear? Please note that. Now we move on to the next measure, that is measure of dispersion. Measure of dispersion indicates the amount of variation or spread in the data set, of course about this central value. So the deviation about this central value is what is known as measure of dispersion. How much it spread about this central value is what you mean by measure of dispersion. See, these measures are also known as measure of variations or measure of spread. You can also call them as, instead of calling it as measure of dispersion, if this terminology troubles you, you can simply call it as measure of variation, yeah, measure of spread. Is that clear? Now, as I told you, range is a very simplest measure of dispersion, simply maximum value minus minimum value. Okay, see what generally they say, suppose if you are having data values, there are certain values called outliers. Suppose your values are, suppose your data range is say 28, 36, 42, 56, 90 or 66, 68, 72 like that. Suppose you see 1, 2, 3, 4, very large value. Such fellows are called outliers. Outliers. Okay, in such cases, this range will be sensitive. So it won't represent proper spread, my dear friends, because it is not going to tell you how much is the spread, because there are some outliers which are very varied. Sometimes, wrong values may be noted. Okay, suppose you are entering marks of the student. By mistake, you written 1, 2, 3, 4. It is an outlier, we call it. Of course, there are some methods which they use, in statistics, how to handle these outliers. There are methods. Again, the similar methods are used even in machine learning, my dear friends, when you are doing programming. Okay, in that they have these methods. Okay, generally with pandas, we are going to learn different how to handle this, statistical values. Am I clear? Please note that. So range is not a good measure. Then comes variance. Variance is one of the very important measure for dispersion. So what is variance, my dear friends? It is the average of, see, average means average of squared deviation from mean. Average of squared deviation from mean. Which fellow? For each xi. For each xi, you are going to find this. Average of squared deviations from mean. So for each value, what is the deviation of that value from the mean? So for each value, you are going to find the deviation from the mean. Okay? Squared deviation. Why you are finding squared deviation, sir? See, normally deviation, if you find, there may be some values to the right side, there may be some values to the left side. And suppose here you get 2 and here you get -2, they may cancel out and you may feel like there is no spread, but actually there is a spread. Okay? So to avoid that, we square them so that we get the actual variation, my dear friends. Because of that, squaring is done. Of course, there is one more method. They also take, absolute differences. They are going to find it, but that is having some mathematical issues with that. Because of that, they are going to consider the squared deviations. Average of squared deviations from mean. So each xi, they take it. Take the deviation of this xi from the mean, they take it and square it. Sum of all those squared deviations from the mean divided by number of values. That is what you call it as average of squared deviations from the mean. So this is what you mean by variance, my dear friends. Average of squared deviation, average of squared deviations from mean. Deviation from means xi minus mu is what is called as deviation from mean. How much it is deviated from mean. And it is denoted by sigma square, my dear friends. That is the notation we use for variance. Sigma xi minus mu whole square, where I varies from 1 to n. That is, for each data value, you are going to find the deviation from the mean and you are going to square it and add up all those fellows for I is equal to 1 to n divided by n. See, generally this is called population variance. Actually, there is one more formula called sample variance. Later on, when you talk about, our statistical sampling distributions and all, then we are going to talk about it again. For samples, see, generally what happens when you are having a population, the entire population, if you want to find the variance, this is the formula. But for sample variance, they use this S square formula. In such cases, you are going to use xi minus, so for this is called sample mean whole square, and it is divided by n minus 1, one observation less than number of observation. In case of samples, this is called sample variance, my dear friends. Okay, of course, here don't worry, this is when you talk about sampling distributions. Here normally you go with this formula only. It is for, when you talk about data science and artificial intelligence, then you also need to talk about sample variance. Normally for us, population variance is the regular. See, if nothing is mentioned, by default we consider as population and we consider this as the formula. Sigma square, which is sigma xi minus mu whole square for I is equal to 1 to n divided by number of observations. For sample, n minus 1 you are going to do. That's it. See, there is one very interesting thing which I want to derive and show. See, if you consider this sigma I is equal to 1 to n, You all know a minus b whole square formula, a square minus 2ab plus b square. So I just expand this. This is xi square minus 2xi into mu plus mu square. Divided by n is there, so I write it as 1 by n. I write it to the left, 1 by n. I keep it into the center. Now this can be written as 1 by n. So I can separate this sigma I is equal to 1 to n xi square. Now this one, 2 mu is constant, that can be taken out. Then it is can be written as sigma xi. I am not writing I is equal to 1 to n because sigma means from I is equal to 1 to n. So let me avoid that, so that unnecessary confusions will not be there. So I simply write sigma for that. And this one is mu square constant sigma 1. Now if you consider, this can be written as sigma xi square by n, and this can be written as 2 mu into sigma xi by n. Actually sigma 1 means because I is varying from 1 to n, sigma 1 is added to itself n times. So it is n. So sigma 1 is n. So it is mu square into n, and this n is divided. So this n cancels. So here it is sigma xi square by n, and it is, what is sigma xi by n? Sum of the values by number of values is nothing but mu, because sigma xi by n is nothing but mu. So this is mu into mu square. So it is 2 mu square, and it is again mu square. So what is this answer? Sigma xi square by n minus mu square. And that is the simplified formula for finding variance. This is the simplified formula for finding variance. So what is variance, my dear friends? You can simply write sigma xi square by n minus mu square. Sigma xi square by n minus mu square. See, the advantage of this formula is unnecessary work is avoided. We can avoid unnecessary work. That is the advantage of this formula. Am I clear? And what about the standard deviation? See, actually dispersion means what, sir? Deviation, how much it is spread from the central value. But when you are finding variance, you are taking the deviation square. Okay, so it gives you, suppose your measure is say kilometer, you are finding kilometer square. Sigma square will give you kilometer square, but you have to give the spread in terms of kilometers. So for that we are going to use standard deviation. What is the standard deviation, sir? It is the positive square root of the variance. The positive square root of the variance is what is known as standard deviation. Positive square root. Okay. So whatever variance you get, you take positive square root of that. That is your standard deviation, my dear friend. Okay. And two important results here and here. Okay, let me write it here only. For both variance as well as standard deviation. Okay. Suppose you are having say x1, x2 and so on, xn data values. Okay. Result 1, and here also I am writing for standard deviation. x1, x2 and so on, xn are the data values. So adding constant to each xi. What happens? So sigma square new will be sigma square old. No changes in the variance. No change in the variance. So if you add a constant to each data value, the new variance which you get is exactly same as old variance. Same is the case for standard deviation. Adding C to each xi, the new standard deviation is exactly same as old standard deviation. It does not affect. Adding constant does not affect variance. But multiplying C to each xi. If you multiply each data value with constant, then the new variance is constant square into old variance. Constant square, only constant is squared. This is, see, this is a notation for variance. Notation is sigma square. So whatever old variance is there, that is multiplied with c square. That is the new variance. And what about standard deviation? What about standard deviation? Here, the new standard deviation is C into old standard deviation, because you take under root of that, na? So positive square root, because of that C into old standard deviation. Please remember this. These formulas are important. So let us find the variance here. See, I am using actual formula for variance is sigma xi minus mu whole square divided by n, but I told you I am going to use this formula, sigma xi square by n minus mu square. Some people complain about it, saying that we need to find mean. Anyhow, here also you need to find mean. Without mean, work will not go. Okay, so we have to do that. So I am using this formula, my dear friends. So for that, first of all, I need to find mean, which is sum of the values divided by number of the values. So what is it? 4, 6, 10, 18 by 6, which is 3. Mean is 3. So what is variance, sir? Sigma xi square by n, that is 3 square plus 1 square plus 2 square plus 4 square plus 2 square plus 6 square upon 6 minus mu square, that is 3 square. So simplify this. Hopefully it is 70 by 6 minus 9. I already calculated this, so I am directly writing this answer, sir. 2.666 something you get. So I am writing approximately 2.67. So that is your variance, my dear friend. 2.67 is the variance. That is the variance. Now what about standard deviation, which is positive square root of variance? I think it is 1.63 something. Please verify that. That is positive square root of variance is standard deviation. So 1.63, my dear friends. Of course, you can also, people also use this, tabular form. But why to use tabular form? See, for the tabular form, what they do, like, 3, 1, 2, 4, 2, 6, they do it. And, this is the xi values. So they find xi minus mu values. Then they find xi minus mu whole square values. Okay. So here what happens? What is mean? Mean is 3, no? So 3 minus 3, 0. 1 minus 3, minus 2. 2 minus 3. 2 minus 3 is how much? Minus 1. 4 minus 3 is 1. 2 minus 3 is, again there is one more 2. Okay, no problem. 2 minus 3 is minus 1. 6 minus 3 is, square it, 0, 4, 1, 1, 1, 9. So this is xi minus mu whole square. So then they find sigma xi minus mu whole square divided by how many values? 6 values. So sum of these values divided by 6, that is 10, 11, 12. 12 plus 4 is 16 by 6. So 6 2s 12, 40. 40 means 6 6s 36. So 6666. So 2.67 you are going to get. This is, I'm sorry. What happened to this? Is that clear? So this is how we can find with formula method also, my dear friend. Directly sigma xi square, xi minus mu whole square by n value. With that also you can find it. Some people like this method. You can do by this method also, my dear friend. Where sigma xi squares we need to find by n. Okay, some people they feel like, why to do 2 times, I do only 1 time. But this requires extra calculations. But if you like it, you can use this method also, no problem. Am I clear? This is first method. Using this is method 1 or method 2, and this is with method 1. That is original formula. I used here original formula. Here I use this method. Any method you can use. Of course, the variance we calculated. What is the variance? 2.67. And what is the standard deviation? 1.63. I done everything in a single page. Next one. A sample of, this is a GATE question, a sample of 15 data is as follows, 17, 18 and so on. What is the mode? Which value repeated more number of times? 17, 1, 2, 3, 4 times. 18 is 2 times. 5, no other. 17 is repeated more number of times. So what is the mode? Simple question. See here, this is a very interesting question. If x is the mean of the data 3, x, 2, 4, then what is the mode? See, for this data mean is x, then he is asking what is mode. See, if you want to know mode, you should know all the values and which value repeated more number of times, you should know it. So for mean, what is the mean of this data? Mean is nothing but sum of the values divided by number of values, and it is given as x. So this is equal to x. Means what? 3 plus x. Okay, you can simplify also if you want. 3 plus 2, 5, 5 plus 4, 9 plus x is equal to, you can send 4 to the other side, 4x. That means 3x is equal to 9, yani x is equal to 3. So what is the data, my dear friends? 3, 3, 2, 4. So what is mode? Mode is equal to 3. The spot speeds observed at road section are, I think this is a civil engineering information. We don't have to know what is that. Even I do not know what is that, sir. But for me, the observations are given and he is asking what is the median. I can find it. Median means what? First you need to arrange them in a sorted order. So first arrange them in the sorted order. Here also we have values. So what is the smallest value? I think 32. After 32 we have 40 is only enough. 45, 49. Then we have 50s. Then that is 51, 53. 56, 51, 53, 56, then we all have 60s, that is 60, 62, 66. So you sorted them. So we are having 9 values, sir. How many values given? 1, 2, 3, 4, 5, 6, 7, 8, 10 values. 4, 5, 6, 7, 8, 9. I missed one fellow. Which one I missed? Anything repeated? 60, 62. 66, 79 is missed. 79 is missed. Okay, very good. So n is equal to 10. So n by 2, fifth observation, 1, 2, 3, 4, 5, fifth observation plus sixth observation divided by 2. That is the median. So what is median, sir? 109 divided by 2. 2 5s, 2 4s, 0.5. 54.5 is the required answer. Is the idea clear? One more question. Marks obtained by 100 students in an examination are given in the table. Then he is asking what about mean, median, mode. So generally people find mean, but for this what is easy to find is median and mean. Median and mode are easy to find actually, because if you see they are in the correct order given. These values are given in the order 25, 30, 35. These are the marks and number of, these are the frequencies. So this is xi and these are the frequencies. So we are having 100 values. 100 means 50 and 50 first observation. How to find median, sir? How to find median, sir? 50th and 51st observation divided by 2. So if you see 20 values are gone here. 20 values are gone here. So 50th and 51st observations are here only. That is both are 35. Both are 35 means 35, 50th observation, 30, 51st observation is also 35. That is from 41 to 80th observation, all are 35 only. That is 35 is repeated 40 times. 35, 35, 35, 40, it is repeated 40 times. So in that 50th observation is 35, 51st observation is also 35. So 35 plus 35 divided by 2. So what is median? Mode. Which value repeated more number of times? Which value repeated more number of times? So here if you see frequencies, you see which fellow is having highest frequency? 35 is having highest frequency. If you observe, which one is having highest frequency? 40 times it is repeated. That is 35 is repeated 40 times. So which one is repeated more number of times? 35. So mode is 35. Median is 35. Mode is 35. So you can see median 35 and mode 35 where you are having. So that is the answer. I not even find what is mean, sir, but still I could able to get the answer. Elimination of the cases, because mode and median 35 only in this case. So remaining all are ruled out. Got it? If you want, you can find mean also. What is the mean formula, sir? You can use sigma fi into xi divided by sigma fi. Use this formula to find the mean, my dear friends. That is 25 into 20, 30 into 20, 35 into 40, 40 into 20. So if you simplify, I think how much you should get, sir? Sum is 3300, not this one, I think, a different one. I not noted this value. Maybe this one only, 3300, yeah, this is the value. And sigma fi, sum of this 100 students, here you don't have to add them, 100 students he mentioned. So 33 is the mean. Even that you can solve. So that is about your statistics basics required, my dear friends. Now you may ask me why you require statistics, my dear friends. See, actually now we are going to start with probability, random variables, and then we are going to move on to the probability distributions. See, statistics characterize data or distribution. Now we are having statistic distributions like probability distributions. Whenever you are having data or distributions, whether it is normal regular distributions or probability distributions, we need to characterize it. To characterize that, we need to use statistics. So that's why we introduce the idea of statistics here. So now we talk about probability distribution. Even for the probability distributions, we are going to discuss the statistical terms, like what is mean of the distribution, what is variance of the distribution, that we are going to discuss. Because of that, we discuss the statistics basics here. And some of the questions you already seen, they are asked in your examination also. Okay, so that is about statistics, my dear friends. In the next class, we start with random variables. The next class is about the random variables. Got it? That's all for today. If you have any doubts, you can ask me. Otherwise, that's all for today.